Hello everyone, this is our second video lecture. In this lecture we will discuss about functions. Previously we have already discussed about relations. So here in this case we will discuss about function. So what is function? Function is a special type of relation. We have two perspectives, we have two notion about function. First we will discuss about the first notion. What is that? Function is a special type of relation. We have already learned about relation. So if f is a relation between a and b be two non-empty sets, then if it is happen to be a function, it must obey two conditions. What is the first condition? That is, for each a belong to capital A, there exists a b belong to capital B, such that this pair a comma b must be belong to f. So what is the special in this? That is, each and every element of capital A should be assigned to any element of capital B, and they will make a pair, and that pair must belong to the relation. This is the first condition. And what is the second condition? That is, if a comma b, that is, if a comma b, this is a pair and this is belong to the relation, as well as a comma c, this is also a pair and this one also belong to this relation f. That is, a is assigned to two different elements, that is b and c. If f is happen to be a function, then b must be equal to c. So these two things you should keep in your mind. First of all, that each and every element of the first set will be assigned to any element of the second set of the relation, and each and every element of the first set, that is capital A, has a distinct pair as in the relation. Okay, so this is the notion of first kind. This is a notion about as a relation of a function, but this notion is not quite useful for the development of this subject. Okay, so for this course we need another notion. What is that? Function as a correspondence. Okay, so what is correspondence? That is, you have already learned about function in your previous class. Here in this class we will just discuss about the character of the different functions, the character, how we like to divide the function in the basis of their correspondence. So you have already know the definition of function. What is function? If a correspondence or if a association is happen to be a function, that then two conditions should be obeyed. What is the first one? If f is a function from a to b, that is, a is a non-empty set and b is also a non-empty set, then first condition is what? All elements of a associated with the elements of b. That is, there should not be any element which is skipped. Each and every element of a should be associated with some element of b. Okay, so and the second condition is what? The second condition is an element of a associated with the unique element of b. So what does it mean? It means that if a, b, these are the elements and these are the elements. So let us consider the first element. If f is happen to be a function, then it will not happen. That is, a is assigned to the first element, that is a, and a will also assign to the second element. It will not happen. Okay, if f is happen to be a function, then the images of the elements of the domain will be unique. Okay, so here what we can observe, that is, if f is a function from a to b, then each and every element should be assigned. Okay, so in the codomain there may be some element which can skipped, which may not have some pre-images, but the elements of the domain must have an association with the elements of this codomain. Okay, so now we have already know what is domain of the function, what is codomain of the function, and what is range of the function also. We have already know that, we have already learned about that in our previous class. Okay, so go to the next topic. So, and the next very much important, what is that? You must know the graph about different type of functions, the modulus function, greatest integer function, logarithmic function. So it is not for the, not for your this chapter, it will help you for another chapters also. So the main thing is that if you can look the if you can look the mathematics, or if you can look your upcoming chapters in the eye of function, then you can easily interpret each and every topic as a function. There is a certain domain, there is a certain codomain, whether it is a matrix, whether it is a determinant, it is an integration, it is a differentiation, whatever it may be. Ultimately these are nothing but the function which has a certain domain and certain codomain. So go through this chapter very carefully and make a strong notion on this chapter. Okay, and just keep remember the standard graphs of the different type of standard functions. What is modulus function, greatest integer function, logarithmic function, exponential function, these are. Okay, so let's go to the next slide. So here we will divide the function in the character, in the basis of the correspondence, the number of correspondence which it has in its codomain. The first one is 1 1, otherwise it is called as injective. The second one is onto, it is called as surjective. And the third one is bijective, or if a function is both 1 1 and onto. Now you may be heard about into function, many one function from different sources. So into and many one function, these are nothing but the special type of 1 1 function and onto function. Okay, so we will mainly focus on these three categories of function only. Okay, now, so what is 1 1 function? A function f is said to be 1 1 if different elements of f have different images in B. So what does it mean? It means that if A and B be two sets, and these are the elements of A and these are the elements of B, then what is called 1 1? That is, the assignment of each and every element of A should be unique. It doesn't mean that it will not happen that if this one assigned here and this one also associated with the same element, it will not happen. Okay, it will not happen. So the assignment or the association to the each and every element of the domain to this codomain will be distinct. Okay, so mathematically how we can judge the what if a function is given to us, whether this one is uh, 1 1 or not. Two condition that we have to keep in our mind. In two ways we can proceed, and we will take the methods in merits of the problems. First one is what? First one is if it will say that if f of A equal to f of B, if first one is that what is if f of A equal to f of B, then it is always implies A equal to B. Okay, so what does it mean? What we can say verbally, that is, if f of A and f of B are the elements of images, are the elements of codomain, they are the images. So if the images of two elements is same, then the original two elements of the domain happen to be same if the function is 1 1. Okay, and other word, contrapositively, what we can say, that is, if the two elements of the domains it is not same, that is, they are not equal, then if a function is happen to be 1 1, their images also will be not equal. That is, if A is not equal to B, then f of A also should not be equal to f of B. Okay, just look at just pause when you watch the video, just pause at a time and just look this diagram at a while. You will get the answer. Okay, now so formula, and so here what we observed, so what is one of the condition that if f is happen to be a function, so what is one of the condition? That is, here on the above diagram you can easily observe that the cardinality of A is 6 and the cardinality of B is 8. These two sets contain two different number of elements. Okay, but there are certain existence of, we can see that the certain existence of an 1 function if we see the diagram carefully. So every element of A has a unique correspondence to an element of B. So it can be easily realized that by the above diagram for 1 that is, for 1 function it is not necessary that the cardinality of the domain set always should be the cardinality of equal to the cardinality of codomain set. But what is the necessary condition? That the cardinality of the domain set is always should be less or equal to cardinality of codomain set. N of A always should be less or equal to N of B. That you should keep in your mind. So it is one of the condition that if f is happen to be a 1 function, if this condition violates, then there doesn't exist any question that f is whether a function 1 function or not. Okay, now so formula to find out the total number of functions from a set to another set. So I think you already know the you have a notion of such kind of formula, because maybe it is already discussed in class 11. So what is that? The total number of mappings from A to B, whether the number of elements in capital A, that is in codomain, is cap n, and the number of elements in codomain in is m, whether the total number of mappings from A to B is m to the power n. Why it is m to the power n? Because for m number of elements in its codomain, we always have n number of choices. Okay, so for this cause we have the total number of mappings, that is m to the power n. So this is a very important theory, you should always keep remember this one, and based on this theory you will get you may have different type of question also. Okay, and this is a special formula, that is formula to find out the total number of 1 function from A to B. If f is a 1 function from A to B, f is unknown to us and the cardinality of A is n and the cardinality of B is m. So what is the total number of 1 function? This is this one. The total number of 1 function is factorial m by factorial m minus n. So why it is? So this is the only question that I want to keep before you. So you will just make the solution of this question, and I will be happy if you send me the answer, that why the number of relation between A to B, whether the cardinality of A is n and the cardinality of B is m, is always been factorial m by factorial m minus n. So this is the one question that I want to keep before you. Okay, so this is a very important notion, this is a very important formula also. We must remember this formula and we will apply the formula while we get such kind of problem for solving. Okay, so now these are basic some problems which may become whether the function is 1 or not, if it is asked to check. So here f is a function which is given and defined as fx is, what is fx? Fx is 3x plus 4 for all x belong to R. So f runs from R to R. Okay, f runs from R to R. R is domain as well as R is codomain, and f is defined as 3x plus 4. So prove f is 1 we have to find out whether f is 1 1 or not. So how we will check? We will check the first method. We will take the first method, that is if the images are same, and if we can easily show that the images are the pre-images are also same, then we can say that f is 1 1. So here uh, we have already taken two elements, that is x1 and x2, from the domain set, and we got the we just considered the images are same. If we can derive that the pre-images, that is x1 and x2, these are two same, then we will say f is 1 1. So we have already put the expression, and after calculation we get into x1 is equal to x2. So we can, what can I say? We will say the above function is 1 1 function. Okay, I have already make a note, and in this note you will get the same number of problems, same problems which I solved as an example. You can check over there. Okay, now if it is asked that whether the second one, whether f runs from R to R plus, here the codomain has changed. We have already changed the codomain. What the codomain we have already considered, that is R to R plus. So we have to and the function is defined as fx equal to x square. This is the function which is defined as. So you already know, if we consider y equal to x square, this will indicate a parabola, and whose direction to the upward, which has upward direction. Okay, so here how we can check whether this function is 1 1 or not. Okay, so here we will take the contrapositive method, the second method that we have already observed. If the images are not same, if it does imply the images if the elements of the domain is not same, if it does imply the images are also not same, then we will say that the function is 1 1. So what we have already taken, that is 1 is not equal to -1. We consider two different elements, and we got the images as well by putting the numbers in the expression. That is, for 1 we have already we must get 1 also, and for -1 there we also get +1, because it is x square, it always give the positive value. But these two images are same. For two different element we got the same image. For this cause we will say that this function is no longer a 1 1 function. Okay, we have considered two different elements, and for two different elements we have got the same image. They make this association with the same element, so we will say this function is not a 1 1 function. Okay, but if we change the domain, that is, if we change the domain from R to R plus, and we keep the codomain same, then what will happen? Then let us consider two different elements from its domain, that is x1 comma x2, and its codomain, its images are fx1 and fx2. We consider that they are same, fx1 is equal to fx2. Then put the expression x1 square is equal to x2 square, and after factorization what we have, x1 minus x2 multiplied with x1 plus x2. But we will always consider the solution as x1 minus x2, because the solution x1 plus x2, this factor, the solution that we will get from this factor would not exist in this domain, because all the numbers are same sign, all the numbers will have the same sign, that is plus. So we will always accept this solution only. So from this one we can derive x1 is equal to x2. We will not accept this solution. You can realize that. So what we have observed, we consider two images and we get into they have the same pre-images. They have the images of the same elements. So look at here one thing very carefully. first we have considered the same expression, their domain was different. Here the domain is different. In the previous problem, the domain, the domain was R. For this cause it was not a 1 1 function, and if we change the domain, we change the domain to R plus, then the function turn into a 1 1 function. For this cause, if a function is the nature of the function, always remember the nature of the function is not only depends on its expression, it also depends on its domain. So the same function may be turned into a 1 1 function, or may be turned into a not 1 1 function by changing its domain. So always keep remember this thing. Okay, now on to function. So we have already learned about 1 1 function. So now let's discuss about onto function. So what is onto function? If f is an on, if f is said to be onto function, f is said to be onto function if every element of its codomain, if every element of its codomain will have some images, or for every element of B or its codomain there exists a pre-image on the domain set A. Okay, it is that for every element of its codomain there must exist a pre-image, okay, in the domain set. So here in this diagram you can easily find out that every element of B will have a pre-image, on A. So the above mapping is onto, so F is onto, then what is that? That is the cardinality, of B, the cardinality of if F is onto, then the cardinality of B should be less or equal to the cardinality of A. Okay, the cardinality of B, here I have written by mistakenly, it is mistakenly written there, is the cardinality of B, that is the cardinality of the codomain set, should be less or equal to the cardinality of domain set. Okay, so how we can check whether the function is onto or not? If f is supposed to say a function which is given here, and the domain is R as well as the codomain is also R, then if it is given that fx equal to 3x plus 5, this is the function is given. So how we can check that this image, that is y, is associated with some element of its domain? So y equal to 3x plus 5, and we can derive from that x equal to the value of x equal to y minus 5 by 3. So for an image, y to the codomain set, we will have a pre-image x in the domain set. So here f is a onto function. We can find out the pre-image. Okay, so from this one, from if such algebraic expression is given, we will consider the fx as y, and if we can derive that, if we can find out the value of x from that expression, then we can easily say the given function is onto. This is the main thing. Okay, here we have done the same thing. And one thing you should remember, if a function is onto, then the range set always be same or equal to the, the range set is always same or equal to the codomain set. This is a very important notion. You should always keep remember this one. Based on this theory, many problems will come, and we'll solve this problem based on this theory, that is range of the function. If a function is onto, then the range of the function is always be equal to the codomain of the function. Okay, now check whether the given function is onto or not. The given function is that, what is that? Fx equal to x square, and we have to find out that this function is onto or not. So what is fx equal to x square, and this one is the, and you should remember that the domain and the codomain, here the codomain is r and the domain is also r. So if we graph this function, then what we have, we will have a parabola. So we don't have, so for the, okay, so here the range set of f is kept r plus, the range set of f is r plus, because fx equal to x square will always give us a positive value. So the range set is r plus, and the codomain was r, and this is strictly a subset of r. So what I have told you before, if f is happen to be a onto function, then the range set is must be equal to the codomain set. Okay, but here what you observe, this is not equal, so f will be no longer a onto function. But we can make this one as an onto function if we change the codomain as r plus. If we change the codomain from r to r plus, then we can make it as a onto function. So here the codomain also matters, okay, for a function, if it is whether it is onto or whether it is on 1. Okay, now the last topic, that is bisection. So what is bisection? This is not a fundamental theory. If a function is 1 as well as the function is onto, then the function is said to be bisection or a bisective function. If f is a function that is 1 as well as this one is onto, then f is a bisective function. So in this mapping, every element of codomain should have a distinct preimage on its domain. Okay, observe that the above domain is very carefully, observe this one is very carefully. You can pause the video and look at here, and here each and every element of its domain has a distinct images in its codomain, and each and every element of the set B is assigned to a distinct element in the set domain. Okay, for this cause f is 1 as well as f is onto, so f is a bisective function. And if f is a bisective function, then we will always get this condition, that is the cardinality of A always should be equal to the cardinality of B. Okay, so if it is asked that whether the given function is 1 bijective or not, and if the cardinalities of the domain and codomain is given, then for the existence of the bijective function, the cardinality of domain set should be equal to the cardinality of codomain set. If they are not equal, then there doesn't arise a question that whether there is existence of the bisective function or not. Okay, now I have already considered a function and how such kind of question can be asked to you. A function can be given to you. This is a very familiar question, this kind of question, and this kind of question will be asked in your exam definitely. So if a function, if an expression is given, this is a bisection. If an expression is given, then check whether this expression is whether this function is bijective or not. Okay, so first we will check 1 whether this one is on 1 or not. So I have written this expression, and here I have proceed in that way, that is f of x1 is equal to f of x2. Here I forgot to write, that is, let us consider f of x1 is equal to f of x2. Then we have proceed in such a manner, and we have get into this line. Okay, now this quantity always be greater than equal to 0, because x1 square is greater than 0, x2 square is greater than 0, and x1 and x2 these are happen to be and we have considered these two elements, that is x1 and x2, and their multiplication also should be greater than 0, and plus 1, this one is also greater than 0. Okay, so here in this case this one is greater than 0, so this one is no longer equal to equal, so we'll equal this quantity to 0, and what you observe, that is x1 is equal to x2. So f is 1 1. So we have already proved that f is 1 1. Now we like to prove f is onto. So for that we consider that y equal to fx, and we have already derived this line, that is x cube plus x minus y equal to 0. Now look at here one thing very carefully. This is a cubic equation of real numbers, and you know that each and every odd degree equation has at least one real root. Okay, if we plot the curve of this function, then the curve at least cut at once the x-axis. Okay, so for this cause we will get at least one real number, and that real number is the pre-image of y. So there exists an m which is belong to r, this real number, such that should be there exists a m such that this is equal to y. So y has a pre-image on its domain set. Since f is 1 1 as well as onto, so f is bijective. So at first we have already proved that f is 1 1. After that, what we have proved? We have proved that f is onto by this theory. So here, that's why we can combinedly say f is bijective. Okay, the next one, this is a very important function. You have already know this function very well. What is that? The greatest integer function. So I have considered the greatest integer function whose domain is R, and as well as the codomain is also R. Okay, so we like to find out whether the function is bijective or not. So let us check whether this function is 1 1 or not at first. I have considered, so for this cause I have considered two elements, x1 and x2. These two elements are different. You can easily find out that x1 is 1.25 and x2 is 1.35, but being two different elements, they have the same images, that is if x1 is 1 and if x2 is also 1 by the property of greatest integer function. So it doesn't imply that x1 not equal to x2 is not equal to fx equal to, imply, it doesn't imply that we have two different element, and for this cause we get two different images, but they give us the same images. Okay, two different element and they assign to a same image, that is 1, and here it is 1.25, here it is 1.35. For this cause f will not be a 1 1 function. Okay, and when it violates the first condition, that is f is a 1 1 function, then there doesn't arise a question for further checking whether this one is bijective or not, or onto or not. Okay, but we can easily find out whether this one is onto or not. Why? Can you tell me whether this function is onto or not? Yes, this function is neither onto. Why? Because the codomain, the range of this set f is z, that is the set of integers. You know that very well. The range set, if we consider the set of real numbers as its domain of this greatest integer function, then we will get the range as set of integers, that is z, and this one is a subset of capital R, that is codomain. So they are not same. For this cause this function f, there is greatest integer function of s, is not onto also, is not onto also. Okay, so we have to tackle the problem by different theories, and we have to know where should we impose which theory. Okay, and this basically depends upon the merit of the problem. Okay, now the next thing is that this function is a very well known function, fx is equal to e to the power x, exponential function. We have to find out whether this function is 1 1 or not. First 1 1 and second 1 2. So here what is asked here is proof that f is 1 1 but it is not on 2. So fx equal to e to the power x we have considered, and we will go through the first notion, that is we choose the same images fx1 equal to fx2, and we can derive by the property of exponent, that is x1 equal to x2. So we can easily say f is 1 1, but f is not 1 2 on 2 because the range set of f is r plus, and r plus is a subset of r. So it is the codomain of the function e to the power x that we have chosen here. So here in this case, in this fixed codomain, f is not onto, but it may be onto function if we change the domain r plus from r. Okay. So for proving any function to 1 1 or not, or to determine neither of the function, it is very important to know the graph of the function. In future we will discuss about the graph of the function. It will take another class. That in that class we will discuss about how we can easily uh, find out whether the function is 1 1 or not if the graph of the function is known to us. We will take different type of graphs of different type of functions. We will change the domain, we will change the codomain. That's why the graphs will also be changed, and for this cause we will get different type of characters of the function, whether the function is 1 1 and it may be turned into a not 1 1 function. So on that case you will just check the graph of the function at a glance, and I think that time you will able to understand whether the given function is 1 1 or not by just checking the graph and without any calculation. Okay, thank you for the day. Okay.